Hello guys, welcome to the reinforcement learning series. This video will cover an intro about OpenAI Gym API. So the Python library called Gym was developed and has been maintained by OpenAI. You can visit it at this address www.gymlibrary.dev. The main goal of Gym is to provide rich collection of environments, as you can see over here, for a reinforcement learning experience using a unified interface. So it is not surprising that central class in the library is an environment which is called env, as you can see over here. So basically, instances of this class expose several methods and fields that provide the required information about its capabilities. At a high level, every environment provides some pieces of information and functionality. They are a set of and these are like a set of actions. Okay, basically that is allowed to be executed in environment. Gym supports both discrete and continuous actions, and along with the set of action we have shape and boundaries. So basically the shape and boundaries of the observation that the environment provides to the agent, and step. These all are functionalities. A method called step to execute an action which returns the current observation, the reward, and the indication that episode is over. And one more is like reset. So a method called reset which returns the environment to its initial state and obtains the first observation. Now we'll study about some important things. So these are the action space. So the action space that an agent can execute can be discrete or continuous. So we have two types of actions, discrete and continuous. And discrete actions are fixed set of things that an agent can do. For example, directions in a grid like left, right, up, down, like we have studied this before. It's a grid, and going right, down, up, left. So these are all discrete actions. Another example could be push button, which could be either pressed or released, like a push button, either hit it, or when you will not hit it, it will get released. So that thing. And both states are mutually exclusive, because a main characteristic of a discrete action space is that only one action from finite set of actions is possible, and the other is continuous action that has a value attached to it. For example, a steering wheel which can be turned at a specific angle, or an accelerator. So this is the steering wheel, and sorry about my drawing. Either we're going to rotate it here, or even the accelerator, which can be pressed with different levels of force. Description of continuous action includes the boundaries of the value that action could have. In the case of steering wheel, it could be from minus 720 degrees to 720 degrees. For an accelerator pedal, it is usually from 0 to 1. And of course, we are not limited to single action. The environment could take multiple action, such as pushing multiple buttons simultaneously, or steering the wheel and pressing two pedals. To support such Gym cases, Gym defines a special container class that allows the nesting of several action spaces into one unified action. And along with the action space, we also have the observation space. And when we talk about observation state, just like I've said in the earlier videos, this is our agent. It performs an action in the environment. It gets reward, and the second information channel we get is the observation. Observation can be as simple as bunch of number, or as complex as several multi-dimensional tensors containing color images from several cameras, or whatever sensor you use to gather the information from the environment. An observation can even be discrete, much like action spaces. An example of a discrete observation space is a light bulb, which could be in two states, like on or off, given to us as a Boolean value. And if we go back over here and we talk about the simple classic control thing, so we have here is the very famous cart pole environment. There are other classic control groups things also, but we are going in this video we're going to study about cart pole. So basically this environment is from the classic control group, and it's just is to control the platform with a stick attached by its bottom, as you can see over here. And the trickiness is that this stick tends to fall right or left. You need to balance it by moving the platform, that is this black box, to the right or left on every step. The observation of this environment is 4 floating point numbers containing information about the x coordinate of stick and stick center of like the information about the x coordinate of stick center of mass, its speed, its angle, and of course by applying some math and physics knowledge it won't be complicated to convert these numbers into actions when we need to balance the stick. But our problem is this: how do we learn to balance the system without knowing the exact meaning of observed numbers, and only by getting the rewards? The reward in this environment is 1, and it is given on every time step. The episode continues until the stick fall. So to get a more accumulated reward, we need to balance the platform in a way to avoid the stick falling. We reset the environment and obtain the first observation. So let's do it, implement it. So here we import our gym library, okay, and this is our environment, gym make, and as we have chosen cart pole, and I'll share you with the library that you must install before proceeding in this code, okay. And I'm going to write observation, so let's print it, okay, observation, that's it. Now let's execute it. So here we have the 4 numbers, and let's check how we can know this in advance, okay. And oops, and along with this we have okay. So like as you can see, the action space, that is the discrete that is of the action space field is of the discrete type. So our actions will be just 0 or 1, where 0 means the platform to the left and 1 means to the right, as you can see over here. And the observation space is of box 4, which means a vector of size 4 with values from negative infinity to infinity interval. And if we write over here like the let's execute it. Okay, so here we pushed our platform to the left by executing the action 0 and got the tuple of 4 elements, a new observation which is a new vector of 4 numbers, a reward of 1, and the done flag with value false, which means that the episode is not over yet and we are more or less okay. Extra information about the environment which is an empty dictionary. And now we will use the sample method of the space class and on the action space and the observation space, and let me show you that. So we have action space, this is the sample method, and okay, at the observation space, sorry, oops, spelling mistake. Let's again execute it. So here it is. This method returns a random sample from the underlying space, which in case of a discrete action space means a random number of 0 or 1, and for the observation means a random vector of 4 numbers, as you can see over here. And the random sample of the observation space may not look useful, and this is true, but the sample from the action space could be used when we are not sure how to perform an action. This feature is especially handy because we don't know now the reinforcement learning methods, but we still want to play around with the gym environment. So I think you have enough idea like to how to implement your first random behaving agent for cart pose. So let's do it and see how it is going to perform, and let's begin with the code. So we're going to import the gym library and our environment, of course, cart pole. Okay, and total reward, we initialize as 0, and total steps also 0, and observation, okay. Now we will loop, and we sample random actions, okay, by performing this and using our action space sample method as I have shown you before, and then ask the environment to execute it and return to us the next observation, reward, and done flag. Okay, so observation, reward, done flag, and that's it. How we got this after performing the action. Okay, so if the episode is over, we stop the loop and show how many steps we have taken and how much reward has been accumulated. So we also keep adding the reward we obtained, and of course the total number of steps, and in case if it's found to be done, we're going to break out from the loop, and finally we are going to write episode done, total steps, and total reward. So our episode is done. Total steps as 11, total reward as 11. So now we're going to study about some extra gym functionality, wrappers and monitors. So we'll start with wrappers. Very frequently you will want to extend the environment's functionality in some generic way. For example, imagine an environment gives you some observation, but you want to accumulate them in some buffer and provide to the agent the end last observation. This is a common scenario for dynamic computer games, which one single frame is just not enough to get the full information about the game state. And another example is when you want to be able to crop or pre-process an image's pixel to make it more convenient for the agents to digest, or if you want to normalize reward score somehow. And there are many such situations that have the same structure. You want to wrap the existing environment and add some extra logic for doing something. Gym provides a convenient framework for the situation, the wrapper class. So the class structure is much like this. Wrapper, and the three types of wrapper. One is the observation wrapper. Sorry, what am I writing? And action wrapper and reward wrapper. And we talk about if this observation wrapper, you need to redefine the observation method of the parent, and this method should return the observation that will be given to the agent. And there is one more we have here is the reward wrapper. This exposes the reward method which can modify the reward value given to the agent. And this one, the action wrapper, you need to override the action method which can tweak the action passed to the wrapped environment by the agent. And to make it slightly more practical, let's imagine a situation where we want to intervene in the stream of action sent by agent, and with a probability of 10%, replace the current action with a random one. By issuing the random actions, we make our agent explore the environment and from time to time drift away from the beaten track of its policy. This is an easy thing to do using the action wrapper class. So let's jump into the code. Okay. So first we'll import the gym. Oops. And of course this, I'm typing import the typeware and random function. And our random wrapper class, that is for the action we are using now, and action wrapper. Let's make this we will initialize our wrapper by calling a parent's init method and saving epsilon, that is the probability of random action. So self environment epsilon, that is we have over the 0.1, and we're going to do some modification in the existing superclass. This is the base class, and epsilon as just like I said. So here is our action function, and if the random is found to be less than epsilon, then we will take the random root and return otherwise we return the simple action. Okay, so basically this is the method that we need to override from parents class to tweak the agent's action. Every time we roll the die, and with the probability of epsilon, we sample a random action from the action space and return it instead of the action the agent has sent to us. So note that using action space and wrapper abstractions, we were able to write the abstract code which will work with any environment from the gym. And now it's time to apply our wrapper. We will create a normal cart pull environment and pass it to our wrapper constructor. And so let's do it. So it's very simple, the random action wrapper and the our cart pull environment. Oops. Cart pull. So from here on, we will use a wrapper as a normal environment instance instead of the original card poll, as the wrapper class inherits the environment class and exposes the same interface. We can nest our wrappers in any combination we want, and this is the most powerful, elegant, and the generic solution. So all the code is going to be same. So actually there are no changes. Total reward, that is initially 0, and we will loop and gather the observation, revolve the flag, and after performing an action in the environment, and add the total reward. And if found to be done, we will break out from the loop and print the reward, total reward. Okay, total reward. So let's see whether our environment is working or not. So let's check. So our wrapper is correctly working, and now let's see the monitor, that's the extra gym functionality, and another class that you should be aware of. And it is implemented like wrapper and can write information about your agent's performance in a file with an optional video recording of your agent in action. And despite this, monitor is still useful, as you can take a look at your agent's life inside the environment. So it is only a single line code that you need to add, that is environment gym wrappers monitor environment, and set it to recording. And if you have already did one, then just simply mention force true to overwrite on the existing one, and let's see whether it's working or not. So our monitor is also working. So I think this both wrapper and monitor, the extra gym functionalities are clear to you, and thank you for watching the video. Please share the video and subscribe the channel.